Easy, man. Easy. I'm Hamish, but a lot of people sometimes they call me Nile River Soldier. You know what I'm saying? Nile River Soldier. Or you can call me Bacteria. Okay? 25 Bacteria or Hamish. Now, we don't want to waste your time. There's a lot of new ones here, okay? So if you're new, just come right here, okay? There's a subscription button, subscribe, so that every time you get notification. Let's get started. So now we have this function. So by looking, we got two type of function. We have this function here, which is logarithmic function. This is logarithmic function. Even by nature of the graph, look. Logarithm most of the time is like this. You know what I'm saying? That's a logarithm. Oh, sometimes it could be like this. It kind of look like exponential. So that's a logarithm when in that form, okay? That's a logarithmic function, just the nature of a graph. Now, also we have a straight line. So there's a straight line here. We see straight line. Okay, now, what do they want us to do? They say sketch shows me. This sketch shows the graph of the function h. And this is h. See, this logarithmic is h. N, L, y equal to L. So what do they want us to do? Excuse me. We have a coordinate of, there's a coordinate here. Let me just check quick. I think I forgot to write the coordinate. I'll follow just a second. Okay, where the coordinate? Yeah, that's coordinate. It's coordinate A. Okay, so this is a coordinate A here. I forgot. Means so if by looking there's a two intersection here, the graph they intersect each other, and here where they meet up intersect. So we know whenever the coordinate the graph intersect, you take those coordinates and then you substitute in any of the two graphs which intersect because they have a common coordinate. Oh, so what we're going to do here, we know the coordinate of A. What is A? X equal to 4. And then what is Y? Y equal to 7. Both a straight line and logarithm, they share the same common point. Same here. Value of B equal to 12. And this is equal to 9. So I might take this, I can take this coordinate A and substitute in either of the two. So what do they want now? They say find the point A and B. These are graph of either intersect at point A and B. Now what do they want? Use the graph to find point P and Q. But where is P and Q? P and Q, it lies on h of x. Oh, so for that case, I'm going to use this coordinate on, because P is on the logarithmic function. P and Q. So I'm going to take the first coordinate, substitute in this logarithmic, and even the second coordinate, substitute in this logarithm, and then I'll solve normal. Why do I do that? Because these points, they lie on logarithm. You know what I'm saying? But if it was something has to do, find the coordinate of straight line, which is this, I was going to substitute this coordinate on here, and this coordinate on here. Let's go. So it can make a lot of sense, because we can just do like we do history, eh? This is not history class, this is mathematical class. You know what I'm saying? So now let's go. So now we're going to say now, so 1 to 4, 7, so start to the 4, 7. This 4, 7, we're going to substitute in logarithmic function. So this is y, this is x. But so what is the y? Y equal to 7, so this is going to be 7. 7, and then equal, log, base 3. Okay, what is the x? X equal to 4. And then minus, pp, and the plus q. Do you know q? No. I'm going to take this one over. You know what I'm saying? Because this stuff is attached to q. So take this one over. It's going to be 7. 7 minus q equal to log. And they have base 3. And then this is 4 minus b. So there's something here I want to show you. It says something called exponential rule. Exponential rule, if somebody give you, if somebody give you log, let's say x. No, let's say this is y or 2y equal to 0. They say find the value of y. So you can apply exponential rule here. How does exponential rule? Exponential rule works. Look, if there's no base here, I mean this is under base 10. So for exponential, you only apply exponential when you have a log on one side and another side must be a number. So how are we going to apply? Now you push this number to this side. So it's going to be equal. This 10 is going to come here and this is going to go up. It's going to become as a power. And then here write 2y. Log disappear. The log disappear. That's how exponential rule works. Divide by 2, divide by 2. This and this cancel. So y equal to any number plus 0 equal to 1, so 1 over 2. Just one more example. So somebody give me log, let's say this is it could be y, and here let's say 3 equal to negative let's say 1. So how much of this exponential? I can apply exponential rule here. Why? Because there's a log one side, and another side there's a number. So how I'm going to do that? I'm going to push this number to the whatever other side. So it's going to become 3, and this is going to become as a power. It's going to raise up, and then equal. See this side, log disappear, and then we write what we left with here, which is y. But this time we say 1 over 3, if you reciprocate, 1 over 3 power 1 equal to y. You know what I'm saying? So that's how you do exponential rule. So I'm going to do the same game here. I'm going to push this one here because I want to solve this question later simultaneously. Why? Because I'm going to do the same thing for the second one. So now I'm going to say, okay, so now I'm going to say push this one here is going to become 3. This is going to be 7 minus q equal to, because 3 come here is going to become 3. This is going to become as a power or exponential. So log is going to disappear and the 3 went there, so we're going to be left with 4 minus p. Oh, 4 minus p. Oh, okay. So 4 minus p. Oh, I can make the p subjects. It's not decided, but I can make p subjects. So for that case now, we're going to say, well, p, if it comes here, is going to become positive. Look, this p come here is going to become positive, and then we're going to take this half to the right. So this p is going to become positive. If you take over here on the right hand side, it's going to be 4. It's going to become minus 3, 7 minus q. Okay, cool. So let me call this first equation. So I'm going to do the same approach for these coordinates. You know why? Because those coordinates also rely on the logarithm function. So what is y? Y equal to 9. So here I'm going to say 9 equal log 3, 3. Okay, bracket, bracket. So what is the x? X equal to 12. So we say 12. And that's going to be 12. And then minus p, and then we plus q, we plus q. So we're going to do the same game. This 9, q come over. So it's going to be 9 minus q. And here we're going to be left with log under by 3, 12 minus p. Exponential rule. Exponential rule, you're going to push this one here. When you push that one there, so what's going to happen? This is going to become 3. 9 minus q equal to, okay, here this is going to fall away and this one went over, so it's going to be 12 minus p. So then we want to make p subjects, you know what I'm saying? So if you make these p subjects, it's going to become p, means this p go to the left, is going to become positive, and then this 12 is going to be here on the right hand side. We take this to the right because we want to make p alone, you know. So you'd rather take this to the right, it become positive, and then 12 take over, it's going to be minus 3 9 minus q. Okay, so this, where is that? Where is the this? First equation and second equation, both equal to p. You know what I'm saying? Equal to this, p equal to this. So I can equate them because this equal to p and this equal to p. So let me take this equal to this. Okay, now we go. So now we're gonna say 4, which is 4 minus 3, 7 minus q equal to 12 minus 3, 9 minus q. Now, so we can get the value of q. How are we going to get there? Take the group of 3 together and group the other number together. You know what I'm saying? So now this is going to go to the right. So here, if this go to the right, it's going to become positive. So it's going to become positive 9 minus q, and then this is minus, which is 3, 7 minus q. And then this side we have 12, and then this 4 is positive. When we go over, it's going to become minus. So 12 minus 4 is going to be equal to 8. Because this is 12, and therefore it's going to be equal to 80. Okay, so then next step, let's split number and letter. So it's going to be 3 power 9 from the log exponential, and then it's going to be 3 power negative q. Number, letter. And then we minus, this is going to be 3 power 7 times 3 power negative q equal to 8. You know what I'm saying? So you see 3 power negative q is common. I can factor that out. And this is common and this is common. Let's take it out. So it's going to be 3 power negative q. So here it's going to be 3 power 9 minus 3 power 7 and then equal to 8. So I can plug that in the calculator. 3 power 9 minus 3 power 7. Okay, this is going to give us, let me check calculator. Where's my calculator now? Excuse me. Okay, so 3 power 9, 3 exponential 9 minus 3 power 7. Oh, excuse me, sorry, I see the mistake here. Okay, minus 3 power 7. Okay, this is going to give us 174. So here it's going to become 3 power negative q, 17496 equal to 8. So since you want to get this, I'll divide by that. You know what I'm saying? I can divide throughout. So you divide by 17496, 17496. So 8 divided by that answer. So 18 divided by answer, and this is going to give us 12187. So this is going to give us 12187, and then equal to 3 power negative q. But what's 3 power negative q mathematical? You know what I'm saying? It's like 1 over 3 power positive q. So if you reciprocate this, it's going to be like 1 over 3 power positive q equal to 1 to 187. So mathematical, you know, you can flip there if you want. Either you can cross or you can flip. So you can only flip if there's no, okay, let's just cross, or let's flip it. If there's no something plus here, then you can, only when you have a one group, you can flip, is acceptable. But not when you have, let's say, plus something, don't flip, okay? Or if you don't want, you can cross multiplication if you want, or you can flip. But me, I'll just flip 2 7 times. So this one you flip is going to become 3 power q. And this is over 1 means 3 power q over 1, and then this is going to be what? 2187 over 1, which is going to be the same thing. So then after, because this over 1 is 3 power q, this over 1 equal to that. Okay, so what we're going to do now, we have to think of 3 power 1 equal to 2187. 2187, I think is 3 power 7. Let's try. Yeah, 3 power 7. So this is going to become 3 power 7, and this is going to become 3 power q. So our q equal to 7. Okay, q equals 7. So if I get my q equals 7, I can get p. Because I can take this 7 here, q, and then I can say, well, what is a pp? I can substitute either here, or I can substitute either there, you know? So now, let's get our p. Okay? So if that's a q, to get p is easy. Because I'm going to take this q, and then I either can substitute in the first equation, because this is a p, or this equation. So whichever one you want. Okay, let me substitute either this or this. So let's substitute. So our p equal to 4 minus, okay, 3, 7. And what is our q? Q equal to 7 also. So minus 7. 7 minus 7 equal to 0. So it's like 4 minus 3 power 0. You know what I'm saying? So any number power 0 equal to 1. Any number power 0 equal to 1. So 4 minus, because this equal to 1 and equal to 3. Oh, so our p equal to 3. Oh, okay. So now we know p and we know q. Our p equal to 3, q equal to 7. Oh, so now our p equal to 3 and q equal to 7. So for that case, I know the value of p, I know the value of q. So I can rewrite my logarithm function. So I don't need this now, I'm done because I need a space. So I'm going to erase this, you know what I'm saying? So let's erase. Let's go quick, erase this, man. We need some space here, man. We're trying to be stingy so hard. So we can have some space in here, okay? Okay, cool. So we got it. Okay, so now I can rewrite because they say, what does it say? Use algebra big. Hence write the question that define h. So this is the question define h. Let's write it. What you waiting for? Oh, so h of x. This h of x now is going to become log. Let me write that out there so I can have more space. H of x now is going to become log under bed 3. What is our x? X is just x minus p. What is our p? P equal to 3 instead of 3. P over 3 and then plus q. What is a q? Q equal to q equal to q equal to 7. Yeah, q equal to 7. Yeah. So now we have a question of p. Alright, man. Whoa, what do they want next? So for the next one, they say b. Right said represent domain and range of h. Domain and range of h. Okay, so what is a h? These are h here. Domain and range. Okay, so domain. Okay, excuse me, just I want to drink the water just a little. Okay, cool. So now we want to go right domain. Domain, let me tell you something. I think we did this yesterday. So, excuse me, I was maybe saying we did it from previous question. Okay. So if somebody give you a logarithm function, let's say somebody give you log of let's say x minus 1, it could be any base. They say this, let's say is g of x. Find domain of this. So back in your mind, you know, okay, so for the logarithmic function to be defined, anything in front of the log, it must be greater than 0. You know why? Because you say log of 0. Don't worry about that. Log of 0. If you plug in a calculator, check your calculator, plug it in, it's going to say error. If you put, let's say, 0.1, it's gonna give you the answer. Plug in the calculator. Why? So any number in front of the log, it has to be greater than 0, not even 0. If you put negative number here, it's gonna say error. It's gonna be greater than 0. Try it. Check your calculator, try. You know what I'm saying? So for that case now, if somebody say find the domain of this, so don't look like, oh, x minus 1, which number? Just say whatever is in front of the log, it must be greater than 0. But what is in front of the log is x minus 1. So I'm going to say domain of g, x are element of all real number, means x must be a real number. But for this case, this, whatever is in here, take exactly, it must be greater than 0. You know what I'm saying? And then after that, you can just solve normal. You say this is, you take over. Oh, okay, so, and then you write x are element of real number, domain of g. You know what I'm saying? So this is your domain. X must be greater than 1. You can even try here. So don't think of a number, just do this methodology. S greater than 1, what does that mean? For example, if you take 1.1, it's going to work. For example, say 1.1. What is 1.1 minus 1 equal to? 0.1. A log of 0.1, it gives us. You know what I'm saying? Try a number, let's say less than 1, let's say negative 2. When you plug in negative 2, it's going to be error. So sometimes they give a log, let's say 2 minus 4. Okay, let's say it can be any number here, let's say 7. And this is f of x. Let's say, okay, tell us domain. So what you want to do, don't look like, which number now? I'm thinking, I don't know. No, just say everything in front of the log, it must be greater than 0 for this type of logarithm function to be defined. Different function have got different methodology. So I'm going to say x minus 2 minus 4. All this stuff must be greater than 0. And then what happened? This is going to go over. So x over 2 greater than positive 4. And then let's put here negative. Let's put here negative. Let's say, for example, let's say this is negative for some reason. You see, so this is negative, and then after that multiply by 2, multiply by 2. So this is going to be negative x greater than, negative is going to come here, right? 2 is going to come here. It's going to be what? 8, because multiply by 2, multiply by 2, 8. So whenever you divide by negative in inequality, the direction the inequality must change. So divide by negative 1, divide by negative this, and this is cancel. So x is going to change that direction because you divide by the negative of inequality. So this value for this function to be defined, this f of x, value of x must be less than negative 8. And here you just write, okay, domain of f equal to x, are element of real number, whereby x must be less than negative 8. This is going to work. If only it's less than negative 8. Let's try this one. If you plug negative 8 here, it's going to be negative times negative 8 equal to positive 80 over 2 minus 4. And this is going to give you 4 minus, oh no, I'm wrong. X must be less than negative 8. What is less than negative 8? Let's say negative 9, negative 12. Okay? So if you say let's say negative 12 times negative, positive 12. And then over 2 is going to be positive 6 minus 4. 6 minus 4 equal to 2. Oh yeah, so log of 2 is going to give you the calculator. So I'm going to do the same game here. Let's say, so let's go back to our question. You know what I'm saying? You know, I want to make sure that you understand all the concepts so you can do this stuff by your own. So I'm going to do the same approach here, right? For this to get domain of h of x, we know anything in front of this log here, it must be greater than 0. You know what I'm saying? So we're going to say, oh, so domain of h, we know x are element of real number, whereby anything is there, which is there, x minus 3, we know must be greater than 0. And then we just take over. So x greater than 3, and they say x are element of real number, or domain of h, whereby, so this is a domain. You can try take a number which is greater than 3, like 4, 5, 6, plug in the calculator, you see, say log, because say greater than 3. So it's going to be, let's say 4. So it's going to be log, base 3 is going to be 4. 4 minus 3 equal to 1 plus 1. You see, this is going to work, because log of 1 equal to 0 plus 1 equal to 1. Check a number, you can try it. You know what I'm saying? So now for this case, this is going to be our solution, okay? The solution is only here. We're done. Now, let's say find the domain, right? Oh, yeah. See, so for this function to be defined, it seems like this graph we did cut at 3 here. Even if it's not mentioned, it seems like, see, look, it did cut here, it seems to be 3. So the domain is like from here all the way, but anything can be defined must be greater than 3. You know what I'm saying? Now let's go. What do we want now? Use the graph domain there. Write down the set to represent domain, range. Okay, range. So for range, okay, so now we go for what? For range. So for logarithm function, range, okay, range, let's go.